Question 2.1, we have a number sequence, a numeric number sequence, and a little bit of an intimidating number sequence because it has, of course, the dreaded fractions. So we have our sequence there that consists of those fractions, and the questions are the same as with any other pattern that we've seen, and we are still we are asked the same stuff. We are asked to do the same things. So the first question is, determine the constant difference of the above sequence. Now, first of all, that is our sequence, and we still have terms, term 1, term 2, and term 3. So all these things are exactly the same. It's just that we're dealing with fractions now. So they're asking us for the constant difference. In other words, how do we get from that term to that term, and then from that term to that term? So in other words, a quarter, to get from a quarter or 1/4 to 1, what needs to be added or subtracted? Now, the reason why this might be a bit challenging or throw you off a bit is because of that 1 in between the quarter and the 7 quarters, or 7/4. Remember that 1 is 4/4. So if I had to rewrite this pattern, it would look like this. It would be 1/4, and that would be 4/4, and 7/4. So because the fraction denominators, of course, stays the same here. So what's actually changing is the number, the amount of the pieces that is changing, because this is a fraction. So here we had one piece of this fraction, which is quarters. Here we had 4 quarters, and here we had 7 quarters. So how did I get from 1 quarter to 4 quarters? Well, it was +3. Okay, but remember, I'm +3 in the numerator, so this is +3. 3 quarters got me to 4 quarters. So I had 1 quarter. To get to 4 quarters, I had to add 3 quarters, and then to get from 4 quarters to 7 quarters, I had to add another 3 quarters. So my constant difference here, and that's just one way of sort of looking at this, my constant difference here is then 3 quarters and 3 quarters. So that's the difference, the constant difference. Of course, and previously I didn't really talk about the sort of rule to calculate the constant difference, which is, and maybe we can just talk about it now. So to get a constant difference, I know that I can take term 2 and subtract term 1. And if that happens, I've got 1, which is, I'll just write it as 4 quarters now, minus 1 quarter, and that'll give me 3 quarters. But then this has to be equal to term 3 minus term 2. Now term 3 here is 7 quarters, and term 2 is 4 quarters, or 4/4, and that also gives me 3 quarters. So that's how I know that the difference is constant. Now, of course, I'm sort of breaking the rules here a little bit by saying that the constant difference is already equal to term 2 minus term 1, because what if this was not the same answer? But we already calculated it to be 3 quarters, so that's why I just used D at the beginning. Usually you would just first calculate term 2 minus term 1, get an answer, and then compare that answer with term 3 minus term 2. Okay, in this case, like I said, we've already assessed this and we've analyzed it, and we knew that it would be the same. I was just then showing that to you by writing it out. But getting back to the question, we have answered the question as our constant difference being 3 quarters, and we can now go and answer number 2.1.2. 2.1.2, determine the general rule for the sequence. Now we know that in our previous examples, we established a connection between the constant difference, in this case it's 3 quarters, and the term position. So we'll start with term 1 immediately. Term 1 is equal to 1 quarter. So term 1 is 1 quarter, And we said, well, let's see how can we connect 3/4 to the term position. And I mean, we know that it is going to be 3/4 times 1, okay, because here we have the term position being 1, and that's the one I'm multiplying 3/4 with. Now 3/4 times 1 is 3/4, which is not equal to a quarter. So how do I go from 3/4 to 1/4? How do I get to that? So I of course know that I can just subtract 2/4, because 3/4 minus 2/4 is 1/4. So and we know that this is going to work for the other terms also, but I'll just do it anyway. So term 2 is 1, but I'm going to write it as 4/4 just to make this simpler. So we again take our constant difference of 3/4. I'm going to multiply it by the term position here, which is 2. So in other words, that's the 2 I'm talking about. And 3/4 times 2, if you work it out, it's 3/4 times 2 over 1. I actually won't use the calculator, because that's not a nice calculator to use. So 3/4 times 2 over 1 gives us 6 over 4. So 6 over 4 is not 4 over 4. So what do I need to do to 6 over 4? To get to 4 over 4, I need to subtract 2 over 4. So it works. And then lastly, let's just try it one more time with term 3. Term 3, I think was 7/4. If I take 3/4 multiplied by the position here, which is 3, and let's just subtract 2/4, and 3/4 times 3 over 1 gives us 9/4. And 9/4, of course, is not equal to 7/4, but if I take away 2/4, I will get 7/4. So it appears that our rule is correct. We need to multiply 3 over 4 with the position and then subtract 2/4. So if I generalize this, I can then say that Tn is equal to my constant difference of 3 over 4 multiplied by the position of n minus 2/4, and I will be able to calculate any term in that sequence.